Hello and welcome back to Calculus 2, section 6.3, there we go, on the disk and washer method. So in this section, we are calculating volume of the object with circular base. All of the objects will have a circle when you cut them perpendicular to the axis of rotation that creates them. If you want to talk about a cone, cone can be created when you take, let's say, y-axis and you rotate a line segment at an angle, like this. What happens is the line segment will create a shape around the y-axis of rotation, and that shape will be a cone. It's also okay to rotate on x-axis. Let's see. Try to guess what these shapes are. So, what would this be? Lampshade, okay. Lamp, shade. I was looking for a cup, but
you didn't put anything connecting to the line.
yeah, I can connect them this way, but those are not functions, so they are bounded, right? They are not infinite objects, because infinite objects would give you infinite volume, and then it's a trouble, right? How about this one? Baseball bat, nice. Yeah, rotate that one around, and you got your baseball bat. So all of the objects that we are considering in this lecture, and that includes your water bottles, includes your tea and coffee cups, includes your these canisters where you can hold the disinfecting wipes and so on, right? A lot of objects which have this you can use to create three-dimensional objects, and then the goal of this lesson is to learn the formula which computes the volume of that exactly. One of the problems for a project that sometimes makes its way onto the project sheet is a problem that goes this way. Go to your favorite coffee/tea shop and then take one of the cups. Go to our cafeteria and take a cup. What is the exact volume of that cup? They're all going to specify 16 ounces or those 32 or 64 buckets, right? You can calculate exact exact volume of those cups, and then use the unit conversion to verify they hold 16, let's say, or more fluid ounces, right, inside. Or if they don't, well, you don't have to go to school anymore, right? So the idea is to now learn how this works. Well, the way I teach this is I first write the formula and then I explain rather than derive it, because it's easier if you already see it written down. Formula that you will be memorizing / reasoning with for the disk method is volume equals pi integral a to b of f of x squared dx if the rotation is on x-axis, and we put a box on it. Immediately underneath in blue, volume equals pi c to d of f of y squared dy if rotation is on the y-axis. Yes, you need both. The top one is rotation around x-axis, which was our baseball bat and lampshade. And then the blue one is the y rotation axis, which was our cone. We all agreed on that? Perfect. Let's understand this formula. Why is this a formula? I hope that you remember from your Calculus 1 course, obviously you should know that from before even, that the volume is calculated when you multiply the area of the base by height, right? So if you want to find the volume of a box, you will calculate the area of its base, b, and multiply by the height, h. If the object is spiky, like a cone, you will take the base and multiply by 1/3 of the height. Right, so that's that, and that covers all volumes that you need to know, right? Great. So now that we understand this, let's take a look briefly at, we can use either formula, but let's use the red one here. If I have the x-axis and I'm going to rotate some function, what are you going to get when you rotate this? A vase, hourglass, right? Yeah. So, do we all see that my f of x is the function on top? I don't need these sides, but that's where my a and b are, right? Would you agree that the radius would be here, and the radius would be there, and the radius is here, so radius changes as the function changes? Because remember, this is where the circle is, right? So each one of these ends here that are along the function are from the radius. So we just equaled the function to a radius. Did we? We did, right? Now, what's the area of the circle? Pi r squared, you say? I know, right? And then we need to do what? Multiply by the height of the object? Well, that's this dx. What's the integral of dx? And x, which is between b minus a, is the length of the object. If you stand this up, is the height, right? This integral here is nothing but simply pi r squared times the height of the object. That's all this integral is. Now, you are not used to f of y dy, but you would like your height, right, to be vertical. So if I am to, let's say, draw a cone over here, right, Now you have your function r, which is f of y, and there is your r squared pi, and the height is from c to d, which is the height of the object, to multiply. Now it's good time to remind you that there is a multiplication symbol in front of dy and dx and so on. And the integral of that dy with the c and d is going to give you the length, which is either length or a height, depending which way your objects or your axis of rotation is. Cool? Of course, cool. It's Calc2. Welcome to 1%. Huh? So please, if you hear these words this weekend, practice. A, what's new? Pull up the chair, pull up the napkin or a piece of paper, and just, explain this. Let's do a few examples and then disappear into the night. What is the volume formula to calculate volume of a cylinder whose dimensions are radius capital R and the height capital H? Volume is pi r squared capital H. Amazing. That's correct. Area of the base times the height. Right? So let's paint the picture. You are tutoring a 7th grader. Formula came up. Right? They had no clue. You just say, right? Not a big deal. Area of the base times the height, pi r squared H. And the kid goes, why? Sleeves back, Calc2, let's go. This is why. We are going to start with our XY coordinate system, and we are going to draw a vertical line of height h, the distance capital R away. And then we are going to rotate that line around y-axis, which is going to create the cylinder. Are we all bueno with that? Good. So this is where the axis comes out. It's going to go through the object, right? So you know that this one vertical line is going to create that. Perfect. What is this quote-unquote function? Well, that function is x equals r on the height from c equals 0 to d equals capital H, because that's the length of the line. The height. 0 to 4, 0 to 10, 0 to whatever the height is. Integral, which means that the volume is pi integral c to d f of y squared dy. We already, copy pi. We already agreed that c is a 0, d is capital H. My f of y is just r squared, and then I have dy. We agree that r is the radius, right? Good. So pi r squared is constant, and all I need to integrate 0 to h is dy. What is the integral of dy? It's like 1 dy. What's the integral of 1?
Y.
X, which means y. Yes, y. So y needs to be computed from 0 to h. This is pi r squared h minus 0, which is pi r square h. And you just derive the formula for the volume of what we call a right cylinder. Radius is r, and the height is h, and you get it by simply rotating a linear vertical line around y-axis, and as that vertical line goes around the y-axis, it creates. Now that line is a line segment. It starts at 0, ends at h, so as it goes around, it creates the finite object of the finite volume, which you can compute, so you can stuff the things inside. Now, let's take a look at one more example at least, and then we'll deal with the washer method next class. So next class we'll finish 6.3 and do 6.4. That will be Tuesday. We are in the other room downstairs, right? I'm going to pick one of these quick vanilla problems we can solve, and then we're done. Here is the problem 19 from the textbook that asks you to calculate the volume for the region bounded by y equals e to the negative x, y equals 0, x equals 0, and x equals ln 4. ln 4 is a number, right? So there's no reason to panic yet. We are going to draw all of the functions that are given to us. We have e to the negative x, which is exponential decay. It goes through 1 and falls to 0 to the right. Then we have y equal to 0. Well, that's the x-axis. And we have x equal to 0, which is y-axis. And finally, we have which shape am I going to get when I rotate this? Curvy cone? What happened with the lampshade? It's perfect. It's a lampshade again, exactly. We are rotating this type like that, and then it will have the circle on both ends, creating a lampshade that has, a little bit of a pointier edge. What happened? A teepee? Okay. Now, it is going to have a circle on top. It's not pointy, right? Because you have the flat piece. Integral 0 to ln 4, because those are our a and b limits on x-axis. We're going to take our e to the negative x and square it. That's the function which you are rotating. And then we have dx. Okay, let's see some algebra and calculus 1 skills to integrate this. So I'll give you about 20 seconds, no pressure. front of the integral. It's time to look at your steps and make sure you have pi on each one. Next lecture is going to have 2 pi. We have integral of e to the negative 2x dx from 0 to ln 4. This is going to be pi times, what is the integral here? E to the negative 2x over negative 2. From 0 to ln 4. Negative pi over 2. And then I just have e to the negative 2 ln 4 minus e to the 0. Can I ignore e to the 0?
No.
That's 1. Exactly. You can't ignore it. It's 1. You only ignore 0 for polynomials. For cosine of 0 is 1. E to the 0 is 1. You can't ignore it. All right, negative pi over 2. Now what do I have? I have e to the ln to the 4 raised to negative 2 minus 1. Negative pi over 2. E to the ln of 1 over 16th. We all went on that algebra? Hopefully. E and ln will cancel. I have negative pi over 2 minus 1. There's your negative there.